All right, example 1. Graph the equation x plus 3y equals 6. And we're going to use an XY chart to do this. I got my XY chart over here. With an XY chart, you pick values that you want for x, and then use the equation to figure out what y should be for each x you pick. There's no rules on a linear equation when x's you pick. I like to pick small numbers. I'm not going to pick 37. I'm going to pick 0 and 2 and maybe -1. Numbers like that. But you can pick anything. I mean, if I pick 37, there's a point 37 comma something that lies on this line. I don't know where it's at. It's way up, way down, but it's not going to fit very well on this graph. So I'm going to stick to numbers that are pretty easy. So to pick x, it goes like this. Pick any number, pick a different number, pick a different number, pick a different number, pick a different number. That's how you pick x. I could go to any 3-year-old kid that knows his numbers and say pick a number, and that 3-year-old kid could get that question right because they know numbers. That's all you have to do to be able to pick x. Any number you pick is correct.
4,000.
4,000 is correct. I wouldn't pick it because I have to graph it. I don't want to graph 4,000 comma something, but you can pick it. Again, I pick small numbers. 3-year-olds probably don't know about negative numbers. They probably go 0, 1, 2, 3, 4 maybe. Or maybe they just heard the numbers 372 that day, so they say 372 because they don't understand what we're doing with these numbers. But the point is, any number you pick is correct. There's no wrong answer to that column. All right? Now, y is dependent upon x. X is independent. The word independent mathematically means it doesn't matter what it is. It can be anything it wants to be. All right? It's like the kids going into college that haven't taken their first class. They can be anything they want to be. And after they take the first class and let's say they make an F- on their first English quiz, they probably aren't going to be an English teacher. I mean, so, you know, and now they're the more the dependent variable. But anyway, dependent. Dependent because it depends upon x's value. That's all it means. So we've got 5 values here. Now for me personally, I don't want to get y equals over here until I get y equals over here. My equation says x plus 3y equals 6, which is a fine equation. I know it's linear because it's x to the first power being added or subtracted to y to the first power. There's no powers other than 1 in it. X and y aren't being multiplied together. It's going to create a straight line. My goal is to get it to say y equals, so I first start by getting y by itself. I move the x to the other side. So 3y equals negative x plus 6. When I move the x across the equal sign, it becomes negative. Then I divide by 3. And I want to divide each piece individually by 3. So that gives me y equals negative x over 3 plus 6/3, which is 2, right? Going back to my chart, do my x's look like good choices?
No.
Why not?
Okay.
X is being divided by 3, right?
Yeah.
So 2 divided by 3 is a fraction, 1 divided by 3 is a fraction, 0 divided by 3 is 0. That's a good pick.
Whoa.
1 divided by 3 is a fraction, 2 divided by 3 is a fraction. So I'm going to get a bunch of fractions. It's not wrong to get fractions. I can get fractions, I can graph fractions. But do I want to graph fractions if I don't have to?
No.
Probably not. So I'm going to leave one of those up there. I'll just leave the 2 up there. We'll get a fraction for that one, just to see what kind of points we get. But I'm going to pick negative 6 because that divides by 3. I'm going to pick negative 3 because that divides by 3. And let's pick, I don't know, let's go crazy and go pick positive 3 also. All right.
Oh my gosh.
I know, it's crazy. All right, so pick some numbers that divide by 3 because x is being divided by 3. So that's another thing you do with independent variables. If you make some picks and you don't like your picks, erase them and pick again. And you're still right, so it's great. So
It's great.
that's all graphing is. That's all it has to be. Graph this thing. Pick a bunch of x's, get a bunch of y's, plot the points, see what picture it makes. That's all it is. All right? So if we go on to get the answers for this. So here's my equation every time. This is how I find y off of x. I go to one of my x's. I'm going to go to negative 6 first. And I'm going to say y equals negative 6 over 3 plus 2.
What?
Okay, so I just took my x value out of my chart. I changed x in the equation to that number. The structure of the equation is exactly the same. I've just evaluated. So I put x equals -6 there. It's minus x. Now it's minus minus 6.
I got a question.
What?
I thought we weren't doing anything with that equation anymore.
The equation determines the value of y every single time.
Well, didn't we just change the independent variable?
I changed the independent variable so it would be easier to work out the equation to whole numbers.
Then why are we using the one from the root? Okay.
This one,
Yeah.
this is the same as this. 6 over 3 equals 2.
Okay.
Okay? To find y, you have to use the equation. It's not like a choice. It's not like the equation's there, but I think y should be this number. No, you can't do that.
Okay.
All right, yeah, the equation has to be used. And again, I use the simplest form of the equation, which is right here. Again, this is not as simple as it could be. That's better. All right, so negative -6, which is positive 6, right? Over 3, which equals 2. 2 plus 2 is equal to 4. So I put -6 in for x. I got 4 out for y. That's my point. So if I look at my chart, -1, 2, 3, 4, 5, 6, 1, 2, 3, 4, this point is on the graph of the line I'm looking for because -6, 4 is there, right? Next point I'm picking is -3. X equals -3 is what I'm picking. Here's the equation I'm going to use to find y. Y equals -x over 3 plus 2. Again, I'm always using the same structure of the equation. I'm simply replacing x with its value each time. Minus minus 3 means plus 3. 3 divided by 3 is 1. 1 plus 2 equals 3. So I put -3 in for x. I got positive 3 out for y. -3, positive 3 is a point on the graph, and I plot the point. Next value I have is 0. I'm doing 0 in black here. All right, so I'm going back to this equation. X equals 0, so y equals -0 over 3 plus 2. What does -0 over 3 equal?
0.
So 0 plus 2 is 2. All right, so 0 for x, 2 for y. That point is on my line. Okay, notice that they're all lining up very nicely, right? Which is good. If they weren't, we'd be having some issues here. Next number for x is 3. So we go back to this equation. Change x to a 3. So it's -x over 3 plus 2. Again, x is 3. The minus sign is part of the equation. So minus, change x to 3 over 3 plus 2. -3 over 3 is -1. -1 plus 2 is equal to +1. Sure. So +3, 1, 1, 2, 3 right, 1 up. There we go. Now, I'm just going to connect the dots real quick with this line. So I'm going to start there and go this way. And when you draw a line, make sure, let me just make that a little bit thicker so you can see some stuff about this line. It's got arrows on it. It's smaller than normal because I dual paged it. But make sure anytime you draw a line, use a straight edge, connect the dots with a nice straight edge, put arrows on your line so I know that you know it continues on infinitely. So Braden's 4,000 he picked, 4,000 from whatever it goes to over here, we'd find that point on that line because it goes on forever, all the way down to 4,000, right? Now the point I picked down at the bottom is 2. All right, I'm just going to erase all this stuff because we don't need it up here anymore. Maybe I'm going to erase this stuff because we don't need it anymore. There you go. All right. So if I go back to this equation here and change x to 2, watch what happens. I get y equals -2 over 3 plus 2, right? 2 is the same as 6 over 3. Right? Just going back to the common denominator form we have up there. -2/3 plus 6/3 is 4/3, also known as 1 1/3, right? Watch this here. So 1 1/3 or 4/3. I'm going to go with 4/3. I prefer improper. But if I go 2 to the right, look where the graph is. 1 and about 1/3. The graph's still where it should be. It's just you have to graph a fraction. You have to estimate its position. So when you get a denominator that doesn't simplify out, so you have this fractional structure, if you pick your independent variables divisible by the denominator, like these four, you're going to get nice friendly results for y. If you pick something that is not divisible by the denominator, you're going to get a fraction you have to graph, so you have to estimate its position. Okay, I prefer to graph integers, so I usually pick things that divide evenly. But again, it's still not wrong to pick numbers that don't. If I picked my initial -2, -2 would have got me 2 2/3. -1 would have got me 2 1/3. +1 would have gotten me 1 2/3. They're all there. All those points would have been plotted. Just harder to plot fractions, so we can avoid them. I would recommend it.